Karma, subscribe. Thank you so much. Thank you so much, guys. I hope you guys are having an awesome day. How are you guys doing? Let me get this a little bit bigger. Hope you guys are doing awesome. Eggplant, my friend. Yes, eggplant. We like the eggplants here. Finally gonna catch Gano for once. What's up, my friend? How are you doing? Hope you're doing fine. How you're feeling about the leg? Well, the leg is what it is. It's hurting. I can sleep a little bit better now, and like it's healing. It's healing. It's going pretty okay. I'm sleeping better, and it is what it is. Maybe at the end of the week I will remove my bandages, because the healing process is going so well. So that's I've got that going for me. UFOs, what's up? How are you doing? Hey, Somi, hey Gondo, I want to see your schlong. Come and see yourself, my friend. Zelus, finally gonna catch Gondo for once. What's up, my friend? Just good, just it works. Yeah, it is what it is. So, today we have two very special projects. As you guys know, I have two projects that I am working on, very important ones. First is the Apollo87H. The Apollo is supposed to be a universal 10 keyless PCB, and the 87H, the Apollo line of PCBs being the RGB ones, right? So Apollo87H stands for Apollo, which is the RGB TKLs, 87 key layout, and hotswap. So it's pretty nice. After we design this one, we will also design a solderable one, RGB solderable one, and we will also design one that is meant for, you know, the universal per key LED, single color LED, multi-layout PCB, which we'll call the Thina. So that will go in. Hello, handsome. What's up, my friend? So compatible with anything that supports the Heine PCB. That's the idea. That's the idea. We do have a compatibility list, which up to now includes GeonWorks keyboards, right? So I contacted Geon, and I've asked him to help me design it and make it compatible with his PCBs, right? And I am reaching out to many keyboard designers around to see if they can confirm that the PCBs are compatible with their keyboards, and soon we will have a pretty big compatibilities. But the idea is to have an open source alternative to Heine PCBs, because those are kind of hard to come by, right? I see many people needing those PCBs, but Heine only sell them in a GB model, which is fine. His PCBs are awesome. Heine is an awesome PCB guy. But I was hired to design an open source PCB, a TKL PCB, because of that. So yeah. And then we have Keeps RGB. Keeps RGB is a 60% hot swap, and it is a per key RGB, but it's the fancy per key RGB with the ISSI chip. And UPAs, that's gonna be sold through Canon keys. Let me show you guys this PCB. I think I have one or two here. Let me get that one, guys. I'm gonna get one to show you. Hold on. Anyways, guys, I can't find the PCB because it's buried deep within my storage, my drawer here, and I can't find it. So I'll show you guys the render, right? And this PCB is a 60% universal 60%, and it's gonna be sold through Canon keys, and it's gonna be open source after it is sold. But Yupa's asked me to adapt it to and some edges that he has, so that's something that we'll be doing today. For Apollo, Gian he suggested some places where we should put standoffs so that the PCB is screwed onto the plate, right? So it doesn't fall off. And we're gonna add those standoffs today. Compat with gummy mount. Yep. Pretty much, you guys are gonna see that. Hello, Gondo. Eu bebi demais vodka. Yes, you drank too much, my friend. It is what it is. Gondo quis entrar lá porque as lives dos mods, milkshake. Não, cara. Eu falei que ia mandar live faz tempo já, pô. Shazan, hello, handsome. Hello, what's up? Anyways, the man, the myth, the legend, Jubert, the man, the myth, the legend. What's up, my friend? How are you doing? Hope you are doing fine, Arinos. Doing well. Hope you are. I hope you are doing well too, my friend. Hope you are doing awesome too. Let me just... By the way, guys, this is a new format, as you guys have seen, so I've divided the stream between this region here, chat and me, and the other one is the full screen. Before that, I had the whole thing on top of the screen, which was not a good idea. This should be easier for you guys to see, right? And it's rendering the PCB, so you guys can take a look. So how have you guys been doing? I hope you guys have been doing awesome these days. So guys, this is Apollo87H, right? Oh, let me move this here. Like here, awesome. There we go. So this is Apollo87H. Pretty nice if you ask me. And it's got processor, per key RGBs, that kind of stuff, this kind of stuff. A little shout out to Gian, because he's awesome. He helped design it. And this is the standard 87 layout, right? So default bottom row, 625 bottom row, only F12, but there will be a 88 Apollo 88H version with Tangan bottom and F13. It will be there eventually. So yeah. Now, Gian sent me a file. Where's the file he sent me? Let's see, he should have sent me a file somewhere. Did I lose it? Is this it? Yes, sir, this is it. Awesome. Josh. So let's do this, shall we? Well, first let's confirm that this indeed works. Looks like it's perfect. Yep. So let's just remove this here because it should be only so much pollution around. So this, and just leave the standoff markings. Okay, so here we have the standoff markings, and we will need to adapt some stuff. You see that he put a standoff here, and this guy will be a little of a problem. I'll talk to him about this guy here, right? This one and these ones should be pretty doable. What have you guys been doing this day, guys? What are you doing while you watch stream? Modding keyboards, that's awesome. That is awesome. R. So this is the guide that we are using. Let's see. Let's see if it's rendered perfectly. Damn, my hair is bugging me. My hair is bugging me. Nice done. Designing a PCB, that's awesome. Gatoron, I love the Gator. There we go, see guys? Here is the standoff. This is the standoff Arino. Did you see Corsair K65 Mini RGB? The PCB there was a really bad image. What do you mean? Let's see. K65 RGB Mini. What's the problem with the image? Oh shit! Look at this. What the actual heck? Corsair. If someone from Corsair is watching this, I will design you a PCB for half the price that looks at least 5 times better than this and probably works better than this. So get this going, guys. Get this out there, okay? Ganda will design Corsair a much better PCB for a much better price, and they're probably paying this. That works. Look at this. It looks like 31FL3741. It does look like an ISSI. This is from the size, judging from the size compared to the diodes here. These are 603s, okay? These resistors and caps are 603s. Now, I would think that this is 3733, but these are resistors, right? And 3733 does not use the termination resistors, so this could be 3741. As for the MCU, there are no markings here, but you can see here SWDIO, SWCLK, so this is SWD, which is ARM proprietary. So this is probably an ARM chip that has been debranded, but they annotated here. Now, these here are tantalum caps, okay? Power filtering, that kind of thing, they goofed. They goofed because there should be some tantalum caps here too, which I believe that these could be, no, these are diodes, right? Yeah, you can see the markings. So these are missing components. These are missing tantalum caps too, okay? This is probably an EEPROM chip, but there are termination resistors here, so it might as well not be. You see a crystal here, right? So you see a crystal, you see 2 crystals. So there is an 8 megahertz and a 32 kilohertz crystal here, which is kind of weird because a 32 hertz crystal is generally used for real-time clock. Is this a wireless battery-powered thing? It doesn't seem to be. So I can only imagine that this is used for some kind of timing, maybe. How much power filtering do they use? What the fuck? ISSI chips recommend that you use tantalum caps. I don't quite remember the quantity and the size, but they do recommend tantalum caps if you take a look at the data sheet, right? You can do without, but they do recommend it. But yeah, this is not good, dude. This is really not good. Anyways, sorry guys, Apollo, and we will adapt. We will add the things here. Now this guy here is one of the standoffs for the hotswap, right? Let's edit the metadata here. This is wood. This is worth, right? Yep, pretty much. They are using a 100 PMC because it has an internal for full speed 8 kilohertz polling. Useless. I wouldn't know if it's useless now. Maybe it has some reason. We would never know, dude. Where is H1? Oh, okay, yeah. There's also the problem of availability, right? Maybe they use the 100 pin one for some kind of availability. It is what it is, man. Can't blame them. Yeah, this here is a little bit of an issue. So you know what's something that would be nice if we could ground the plate. Ooh, that would be awesome. That would be awesome. What? Can we do it maybe? What do you guys think? Should we ground this plate? It does look like a very little cute keyboard though. Like, look at it. Any pictures available? Look at that. I mean, it looks like an N Pro, honestly. Even the fonts. This is weird. Apart, of course, from the space bar. But it just looks like an N Pro. It's just a cab resistor RC circuit? No. Grounding the plate for RMI, we use a ferrite bead. Does the job. Looks just like a ducky as well. Yeah, I mean, it was about time that one of those huge Razer, Corsair, HyperX companies entered this kind of market. But I don't think that they have a chance here, because this market here is already very well dominated by N Pro and Duckies, SK61s, that kind of thing. What I mean is, this doesn't bring anything new to the table, if anything at all. It's a rather limited version of what we have, because this isn't even wireless, whereas, for instance, the N Pro is. Razer went into 60% already. Did they? Didn't know that. I actually like N Pro. My first mechanical was N Pro 2. Yeah, mine too. My first mechanical one was the N Pro 1 in 2014, 13 maybe, something like that. Okay. Is it too big? Maybe we should use an 0805. Maybe an 0805 here would suit this better. Imagine if this one supported QMK, that would be a game changer, but of course Corsair being Corsair. Yeah! It is what it is. I mean, no big company is gonna support QMK because of one simple factor. They want to dominate. What people generally don't understand is that companies these days, and the whole right to repair movement, you guys might have seen that happen. The whole right to repair movement is based on this idea that the companies are trying to push lately, that they should dominate the product life from sale to discard, right? So they want to dominate everything, and that's something that we are trying to change through legislation and regulation, that kind of stuff. But it sucks, man. It sucks that they want to do this. Imagine that they could, right? Imagine if they would. But salve, mundo. E aí, beleza? Tá salvado. Rossman of the United States, I love that guy. He's already vocal about this issue. Rossman of the United States, yeah, what the fuck? What the? Yeah, what the fuck? What the? I don't want to see my own stream come on Twitch. Anyways, yeah, I think that's something that's very legitimate, right? Because F those guys. Like, come on. If I wanna fix things, I should have the power to. I think I should change this huge thing here to an 0805. 1206 is not the best guy here. Let's see. So this is CBW 2012-09U. CBW 2012-09U. 121T. There we go. Okay, this is pretty good. I like this. Oops. First, let's change this symbol here. Nice, okay. Here, awesome. Awesome. Then we're gonna change the parameters for... Did I close it? Am I that huge of a douche? I guess I am. There we go. Oh yeah, this looks much better. There we go. Let's fix this. Perfect. Are you guys hearing this song, this music? The music is awesome. The music is pretty nice, I like it. By the way, what are you guys doing while you watch stream? I know that Mickey is modding his keyb. Jogando aranzinho, chique demais. Where's the render? Here it is. Yeah, it looks much better. Hell yeah. Awesome. Then it's gonna be grounded. Oh, one more thing that I forgot. Let's get this guy here and add some clearance, right? 20 mils, just so we are certain that nothing will happen. No capacitance will destroy our party here. Gondo, what's up? How are you guys doing? Almost ready to sleep already, but a bit late here in Portugal. Tugas, Gondo, God no. Doing good. I'm awesome, man. Awesome. Hope you guys are doing just fine. Pretty hot in here. So I have like a fan 24/7 on my face. Also, I can't go to university. There we go. Perfecto. Perfection. Now for the third guy, this dude here, H3. Now, let's do the same thing that we did before, right? So this guy By the way, it doesn't make sense for me to ground all mounting points, right? So I'm not gonna do that. Let's just do this. Because if one grounding point if one of the mounting points is grounded, then we are perfect. Are we recovering well? I am. The healing process is going pretty well. And I am probably taking my bandages out still this week. So I'm still taking antibiotics for the infection, but it's going pretty well. I am walking better. I'm able to sleep better. It's going well, man. It's going pretty fine. Pretty fine. I'm pretty glad with how it's going because it was very scary. It was very scary, let me tell you that. Okay, done. Here. Then we have this. Page 4. Okay, here we have a little bit of an issue. We will need to do this. This should do the trick better. Okay. Here. Page 5. Glad to hear that. Yeah, man, me too. Pretty happy with the with how it's going. Pretty happy. Okay. Okay. Right. The next one is H6 Serenos. Here, 20 mils. Let's move the logo a little bit, just so we have space here. Then we have page 7. What are your thoughts about the latest trend around curving traces? I read latest version already. Oh yeah, it does support it. For instance, I can do this here. So this, and this, right? Then I can do fillet tracks and a radius like 1 millimeter, right? And it fillets the tracks. Let's do 3, whatever. See? It does fillet the tracks pretty well. What can I tell you? Filleted tracks like this, they are not something that I personally would care for while designing my keyboards, because filleting tracks is something that's only really important for very limited situations, right? So 5 here. So you're able to do this. What do they do to the edges? Convert to a Bezier curve? Yeah. See? It doesn't have the type here, but this is a Bezier curve. This is not like a bunch of traces, little traces. No, this is a Bezier curve here. See? Ending point, starting point, that kind of thing. Now this is coded as a track. It's why you can't see, but from in the back part, it's coded as a Bezier curve. Yeah. It is pretty nice. I am already planning to do a V2 of this, okay, with an ISSI chip. It's gonna happen eventually, but it will take a little bit of a time. Now, when we do it, we will try and do it with curves, with some nice Bezier curves, and it's gonna turn out perfect. But I don't see a point doing it. I honestly don't see point doing it and spending all the time doing it, even because it's not needed for this kind of stuff. Is this the latest nightly? It is. I don't think the latest, but it is from today, or no, it's not from today, I guess. It's from yesterday. From yesterday, yeah. Yeah, here come on, man. Yeah, we'll have to do some major rerouting here. Now the silk screens. Well, Zach Dev, hey, what's up, my friend? How are you doing? Hope you're doing fine, my dude. Doing great. How are you? I'm just fine, man. Just fine. You know, going. Would you consider doing an SMD soldering stream? I have done several already. If you haven't seen those. But I will probably do more for the Lesgoloth. The first PCBs have arrived. I have started assembling them. And when more arrive, I will also assemble them for you guys and do some streams on that. For so long, so long. I don't see any VODs. Yeah, the problem is I didn't keep them. I am horrible at keeping VODs, but I started keeping VODs as of late, and I will keep that going, right? So I will keep those, but as of now, yeah, you can't see any of them because they are lost in the ether of time. Tô querendo fazer uma PCB usando o, porém olhando a documentação fiquei bem intimidado. Alguma dica para o meu conhecimento? Okay, so Lucas Gancia, no. I want to design a PCB using NRF 52840. However, looking at the documentation, I was intimidated. Any hints at getting my electronics knowledge better? I'm gonna ask it in English. If you don't quite understand it, please let me know. The thing about electronics is that when people ask me like how I, these are, damn, they are they're on the opposite side. When people ask me about electronics and how I've come to know how I've come to to graduate in PhD in electronics and how I learned electronics, I always give them this disclaimer that I'm not the run-of-the-mill electronic engineer, and not that I'm special at anything, but my thing with electronics began way before I knew I graduated, right? I've traveled with electronics since I was like 12, so it's been like 15 years since I've started, and it just so happens that the way that you learn electronics, in my opinion, is by doing it. And I tell this to people because most electronic engineers, they've come to see and know electronics in a deeper sense at university or at some kind of formal knowledge process, right? So classes, university, and technical, the formal way you do it. That's not me. I have learned electronics since I'm very hands-on, very passionate. I'm very passionate about this. I'm very proud of this, right? So if you want to learn about electronics, especially for keyboards, I would recommend that you start at the basics, right? So design a skeleton mount keyboard, a simple one. So get a PCB, design one for THT diodes, for a Pro Micro, make a skeleton mount keyboard, which is pretty easy to make. The Akron project is that for that kind of stuff. You can see how that's done. And you can design around that and make that work, right? And when you get the idea of that, then you're going to go to the next step, which is not using a Pro Micro, but integrating the MCU on the PCB as a SMD component. Okay. Then after that, you can design not a skeleton mount, but you can design a 60%, a universal 60%, right, for yourself. You can take like the Arctic PCB and get just the outlines and the mounting points and design one for yourself and see how that goes. And, prototype the PCBs and get them made at a fab and getting to know how the process is, right? And that kind of stuff. That takes years. That takes a couple years for you to get to all this process and do it. It's a very rewarding process, by the way. It's something that's easily a hobby. Nice. nice. There we go. So yeah, that's how I recommend you do it. I recently attempted SMD soldering for the first time and decided to use QFN like a dummy instead of QFP. Yeah, QFN sucks. If you don't have a knowledge of electronics in a deeper sense and you know, some experience with that, you're gonna get slapped. Gondo, you sexy beast, Dark, you sexy man. A brilliant mind, guys, if you know what I mean. How are you doing, my friend? I hope you're doing fine. I hope you're doing awesome. So here it is, guys. The hot swap standoffs. There they are. At least it isn't BGA. Oh, I don't touch BGA. BGA sucks big blue gorilla balls. It's ridiculously hard to do reliably. WLCSP, same thing. Horrible. Should I consider getting a specific tip for soldering iron when working with QFN? Also, it's a microscope recommended. What I would, you know, people ask me about soldering tips and that kind of thing. After you've gotten a certain experience with it, the only tip that I use is the chisel. I have 3 ones: a small, a medium, and a big one, and that's the only tip that I use, even for SMDs, any SMDs, because you can do all sorts of drag soldering. You can do THT soldering with it because it has a huge surface area. I don't use those very little microscopic. I don't know how the like the normal tips are called, like the needle tips. I don't know how those are called. I don't use those. I've never gotten used to those. I use the chisel one, the 45-degree one. That's one. That's not the chisel one, right? How is it called? This here, see? So you see these ones here? Okay, so these ones, I use this one, and an even smaller one. That's all that I use. Those are the best. The freaking best. And I just use those. All of these other ones, forget them. That's my opinion, at least. This here, phew, this here, come on. This here is the thing, and this. Knife. Nah, man. This, I think that this is called a chisel tip. I'm not sure. I know that it's cut in a 45 degree. Zakino is ready with a party of 32. That's awesome. Welcome, guys. Welcome to the PCB design stream. Hola, Gondo. Hola. ¿Cómo está? How are you guys doing? Hello, Mr. Gondo. What's up, Kale? Voodoo Bear. How are you doing, Zach? Thank you so much. Krellbit is following the man, the myth, the legend from Switch Mod. How are you doing? I hope you guys are doing awesome. I hope you guys are doing awesome. Thank you, Ramen, for the Lambo. What the hell? What the heck? Zach is following. Thank you so much, man. What PCB are we working on today? This is Apollo87H. This is a per key RGB hot swap 87 key layout PCB. This is supposed to be a universal one with gummy mount points and that kind of thing. It has a breakable. It has support for GST and a breakable USB-C. So if you don't use it, you can just break this away. Thank you, Ramen, for the Lambo. Thank you. I love ramen and I love rainbows. I love ramens and I love Lamborghinis too. Why my emote? I love you. I love you, Ramen. This is sick. I am also very sick. I'm a very sick person. I love electronics and I deal with them every single day. I'm in love with them. That's pure sickness right there. Gondolindrim, você tem um teclado e-white? I do own an e-white keyboard. I own quite several of them actually. An Alpine, a Vega. Danny Feitas asked me if I own an e-white keyboard. How are you guys doing? Welcome to the stream, guys. I hope you guys are doing awesome. We were just putting these guys here. These are standoffs for hot swap mounts. That's what we are doing them, and we've inserted a couple nice things like grounding them. So this here, quite some awesome stuff. Tem de nada, mas parece ter muitos. Eu falei que tenho 2 ou 3. Tem o Alpine, o Vega e eu acho que tem mais um que eu não me lembro agora. So that's what we are doing today. Hope you guys are doing fine. How are you guys doing? Where do you need to find spacer with those dimensions? Well, of course, I would insert components that I don't know where to find, right? These are available through DigiKey, right? These particularly, you can buy them directly from the manufacturer, which is Worth Electronics. Worth. German. Are they Worth or Wirth? I think they are Wirth because it's U with umlaut, so it's Wirth. Wirth. It's not Wirth, it's Wirth, right? So let me just copy this around. There we go, that's it. Finally found a document with actually Shield G&D app notes. Lots of them have microchips. Yeah, microchip will recommend a RC network, which is something that I don't like using because it does not ground the PCB in the DC regimen, only in AC, and high frequencies also. I honestly don't like using it. I've explained in one of my streams in full the components and what you do to for the grounding shield, but the run of the mill is just a ferrite bead. It's the most efficient and grounds it all throughout the DC and AC. Everyone seems to lean a different way. Yeah, there is no the industry does not have a set way of doing this. The Academy does. There is, if you take high-speed design books, there are some design books on high-speed PCBs, and the books, the Academy and the high-level engineers, they do agree that the best way is the ferrite bead. The only reason why you would use the RC net is if you're not sure if the cable is grounded on the other end, because then you avoid ground loops. That's why you generally use that. But yeah, this is where you find the component. What's up, gang? What's up, my friend? How are you doing? Hope you're doing fine. Okay, so this is okay. I like this. Now this is not version alpha, right? This is actually the RC candidate for pre-beta. So what I'm gonna do is I'm gonna remove the pre-alpha label, and we'll have to add it later. V10, awesome. Can you guys hear the music, by the way? I hope you guys are hearing this music because it's amazing. Pretty nice. Yeah, Jammer. Oof. Awesome stuff, man. Awesome, awesome stuff. We are. Okay, tell me if it's too loud or too much, so I can adjust. Awesome, we did it. Now what we're going to do is we're going to copy this over, right, to Apollo87HS. Now HS is the same thing, but with south-facing spacebar stabs, right? Because that's something that Gian uses. Got an job. Curiosity, how screwed are you? WRT chips shortages? Not much. Really, there apparently the chip that we use are slowly come back in stock. If I remember correctly, we got some here, C86. So, for instance, LCSC has like, as far as last week, it has like 5,000 of these in stock. So these guys do seem to be getting back in stock, albeit, of course, by ramped up prices, but even net megas are ramped up at these time. 32U4 at 3 times the normal cost. Yeah, but look at this. It's just every single one of them is at not at normal cost. So it is what it is. C8 Sedge. Yeah, CB is problematic. Let me see. Let's take a look. 32U4 can suck. Yeah. Yeah, as of right now, they only get C86. Let's see the other suppliers, right? But it's pretty available. Everyone seems to be able to get those right now. Stock. Yeah, DigiKey's out. Mauser got this. Okay, here we go. CBT6 on order. What does on order mean? Let's take a look. Holy shit. Octopart, let's see. CB3s or CB7s? Yeah, sometimes they do have the 3 or the 7s. But if they don't have the 6s, they don't have those two either. It is what it is. Yeah, apparently no stock of this guy here. Well, why does this guy have LCSC? Oh, here we go. See? There's been a few where they've stocked up T3s of other chips and people haven't realized. Really? That is weird. Anyways, they seem to be there, albeit with a little bit heftier price, but they seem to be there. Oof, look at this. BGA, damn, I hate these guys. But yeah, it seems to be there. Let's see this guy here. Sourceability. What the heck is sourceability? Well, it looks like they have some. So yeah, pretty much. I find 0.8 mm VGA is easy enough to solder with a hot plate. For hot air, maybe, yeah. Temperature controlled plate. Temperature controlled plate. I have no idea what that is. Oh yeah, I see. We call this a soldering pad or a heating plate. That's what we call it. Anyways, this is done. Let's see. Hold on. For those RGB LEDs are used in generic Alibaba LED or something else? No, this is SK6812. This is a variant of the WA2812s, but they are back mounted. They are reverse mounted. Now, these do have a problem that they are too power hungry, right? They are too current hungry. So to make them work with a large, I generally don't use them for full sizes. If you want them to work at this larger quantity, you will have to limit their brightness. It works. But it's better to use an SSI chip for this matter. Now, particularly, I have some things against QMK in the RGB sense because the RGB codes are a complete hot mess sometimes, especially with the Wilba RGB code thing. Zark might be able to discuss better on that because he's one of the active developers. But I've always found it really weird to do QMK with that kind of thing. But I will eventually design a V2 of this PCB with a 3741 chip, right, with back-mounted LEDs. So it doesn't require an LED driver chip? No, it doesn't. Every single one of these LEDs, they have an integrated controller, right? They are serialized. So you just admit a 3v3 signal from the MCU here, see? 3v3 signal, it goes into a level shifter. That shifts the signal from 3v3 to 5 volts, and then it goes directly into the first guy, and then it just goes hopping from one to another. Yeah, RGB is definitely a hot mess in QMK, so we're fixing it with baby steps. Yeah, I mean, I'm not complaining at all. I mean, QMK is beautiful. The thing is, it's hard to do RGB for it. It's really hard to do RGB for it. But eventually it will happen, and we will design an SSI PCB for this. Now let's do the Serenos. Awesome. Well, this guy here, as you guys can see, is the same PCB, but with south-facing steps, right? The problem is, this has a little bit of an issue in the sense that it is kept at the same, basically the same repo and as 87. Is this a problem? Absolutely freaking not. But it takes a little bit of a while, so we will have to do. Probably my computer's gonna fry for this, but let's see what happens. Awesome. Then we just copy this over. You see this tab here? We just copy this. Copy this. Delete this. YouTube. Move here. You see my computer is almost committing digital suicide here. But it is what it is. Will your approach result in a higher bomb price? We already have support for 3741. I know. That's why I'm going to use it. Would your approach result in a higher bomb price? I doubt it. Let's take a look at, for instance, Alibaba, which is a supplier. If you're going to manufacture this at a high quantity, they're going to get this at a supplier, right? Someone that does high quantity. So SK6A12 Mini E. So here, see, if you get this at a high enough quantity, it's 5 cents a piece, right? Each PCB has approximately 90, so you can do like 20 PCBs with this, 20, yeah, something like this, 20, 30 PCBs with this. So it is pretty cheap. It's not as expensive as it sounds. See, 10 cents a pop. So you're looking at something like $8, $9 a piece for RGB, which is the same thing that you would pay for the SSI chip. With all the LEDs. So no, this is not a higher BOM material, no. But this is not the ideal way, okay? ISSI is the ideal way, and then again, we will do it, but we need an RGB PCB right now. That's why we're doing this, so yeah. Okay, so now we're going to delete. There we go. Ooh, I forgot. I did something that was not okay. Hold on. Oof, HS. Ooh, okay. Yeah, it's here. Awesome. So there we go, south-facing step. Aren't those 1, 1, 1, 1, 1 used for spacing? No, those are the pad numbers from KiCad. I can show you in a second. That's just a KiCad graphical thing, right? Okay, so it looks pretty, but we do have some problems with connections. What the heck is going on? Why is the clearance so big? What the actual heck? Okay, this is why. This was supposed to be 87GS. What do you mean 87GS? There we go. We do have a rat's nest here. You said you're making one with the south. Yeah, this is HS. This is the one with south-facing steps. Here, see? South-facing, south-facing. Let me remove this. Remove this. 20 mil. There we go. What was the previous version called? 87H. This is 87HS. Done, 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 done. Awesome. Okay. Awesome. This is pretty much it. There we go. South-facing spacebar steps. Looking good. Working from home. I know what it means, dude. Hey, Ghana, hope you're doing well, man. Doing just fine. I mean, not 100%. We're getting there. We're getting there. Eventually, we'll get there, right? Nice looking PCB, isn't it? I love it. I love it. Yeah, looking pretty good. Clearances are okay. I have no issues with this. I'm sending any messages. Come on, render. Okay, this here, do I have any quarrels with this? Oh, yes, I do here, right? So let's do the same things that we did for 87HS. Here, awesome. And this guy, we open up a channel for the ground here. Okay, awesome. Looking pretty bueno. Let's take a look at the quality of the zones here. So pretty bright, just so we can see any zone missing. What trace is this? D51. What the heck? What the heck? Okay. Oh, here we got this guy. Do this should be perfect. Is there an issue if traces are too long? Well, there is the only trace. Let's put it this way: there are two problems with long traces, and this. Especially in the keyboard PCB, the only traces you should expect not to be long, actually two. The two traces you should expect to be as short as possible are the USB traces, because they work at high speed at a differential pair configuration, and I2C, because I2C also works at a very high speed, minimum of 400 kilohertz and generally 1 megahertz. So you should really make those traces small as you can. Honestly, USB 2.0, you can make that work with a wire and 2 tin cans because it's very forgiving. I2C, not so much. I2C, you do need care to make the traces as apart as you can, possibly, and as thick as you can. These traces here, there could be a problem if they're big, because they are also fairly high speed, but not so much, honestly, no. I don't know about PCBs, but it's something that I wondered since some look way longer than others. Let's do an explain me like I'm 5 here. The thing is, When we are working with electronics, we are working at time scales of the nanosecond, of the microsecond, which are very, very tiny microscales. And the thing is, electricity, actually all things, if you take a look at quantum mechanics, but that's another whole story. If you take a look at nature, everything behaves very differently at such high speeds and very small time scales, right? For instance, this 5 volt 3.3 volt trace here, it has a DC behavior. We might classify it as a 0 hertz behavior, which is not entirely accurate, but let's just say that it doesn't vary at all, and that makes it very forgiving to route because it doesn't change much, right? The USB traces, on the other hand, they change from 1 to 0, from 5 to 0 volts very, very rapidly, and that brings you some problems. There are stuff called impedances. Impedances are a nice way that engineers use to designate a phenomenon that we call the relationship between voltage and current. The behavior of current when it's subjected to a certain voltage and vice versa, right? So there is this weird thing called impedance, and when high speeds are at play, that impedance comes to be a real pain in your butt, right? But in order to fully explain this, I would have to get into like electromagnetic theory, differential equations, and that's something that I really don't want to get into. Let's just say that that's a problem. And keyboard PCBs are very forgiving. Keyboard PCBs are something that are very easy to design, and you should only take very care in certain parts of keyboard PCBs. One of them being the USB traces, another one being crystal traces when you are using a crystal. This particular PCB does not use a crystal because of the microcontroller. It has an integrated solid state oscillator. Yeah, the traces are allowed to be different lengths, given that you know what you're doing, but keyboard PCBs are generally very forgiving. Impedance is the equivalence of resistance for an AC signal. It's the other way around. Resistance is what impedance looks like when you are considering in your bandwidth, in a very small bandwidth. Impedance is something that's way more complicated as AC resistance. That's not what happens now. What would your best advice would be if someone get PC design? Not to start designing it. Download KiCad. There are lots of open source projects around, and start taking a look at them. See how it's done, see how they do it, and start replicating it. That's how you start. I wish I paid more attention to my electrical engineering classes. Me too. Me too. It would have saved me so much headache, but hey, it is what it is. Anyways, you might ask, well, why would you only take account of trace length with certain traces? Well, the thing is, do you know the electrical power grid, right? So you have the power grid that delivers electricity to your home. So wherever the power is generated, it's generated at a very far place. That's what we call a microgrid, right? It's generated at a very far away place where generally it's close to the fuel, right? So you have thermoelectrics, which are generally close to coal mines or biomaterial sources. You have hydropower, which is generally close to a dam. You have atomic power, where it's close to the not only close but integrated to the nuclear reactor, right? And that power, which is generated at a place that's close to the source, is brought back to you through a transmission grid, right? So power takes time to be delivered from the place that it's generated from to your place, right? It takes time for it to deliver here, so much so that if you have a blackout, it takes like a couple hours to get back. Here, the thing is, since we are working with such high time scales, when you get faster and faster and faster, the traces, they have what we call wavelengths, right? So you might remember from high school that when you have a wave and that wave gets quicker and quicker and quicker, the wavelength gets smaller and smaller and smaller, such that the traces, they start behaving like transmission lines. The models that we have for traces at high speed are the same models that we use for transmission lines, and that brings its own sort of power. Waves, they have reflections, they have refraction. So electrical signals, they are subject to all of these effects in one way or another, especially in high speeds. So for instance, I can't do this. These are USB traces, right? I can't do this. No, I can't do this. If I did this, this is a source of reflection. The wave, the signal that's coming, is going to have a high rate of getting here and back, and that generates destructive iteration, right? So waves can interact with each other, and a wave can interact with its own reflection, and that can generate destructive patterns that destroy the integrity of your signal, and the PCB simply doesn't work. The MCU simply does not connect to the USB. It can't. In practicality, what that means is that the data that the PCB is trying to get back and forth between the USB is not getting there, because that data is compromised in the middle way, right? So there are all sorts. When you are designing a PCB at a certain high level, especially high frequency, there are lots and lots and lots of second-order parasitic effects that you have to take care of before you know what's really happening, right? So I could be here for days talking about the effects that are here. For instance, this area here, there is a whole reason, at least 5 or 6 reasons why I designed this way, why the traces have to be this particular way, why do they have to have this particular pattern, these particular thicknesses, the particular geometries are very important. So all of that comes into account. It takes endless hours to design this kind of thing in a satisfactory way that I know that's gonna work. At the same time, USB 2.0 full speed, which is what we're using here, is very forgiving to trace for, given that you have reasonability, right? So this trace here is going from the USB directly to the MCU, and it's hard to fuck this up. It's really hard to get this wrong, but you can in any way. Interference, yeah, that's the technical term. When two waves can interact, they build what's called interference. It can be constructive or destructive. The thing is, a wave can suffer interference from its own reflection, right? So even if you don't have two waves but a single one, you can F that up because a wave can have interference from its own reflection. Make me understand why so many people complain about the alt and the control PCB. Well, there is a thing called an auto router or auto router, and what this it means is that, well, this here, all of this was done manually. I have literally traced all of this manually. There are certain programs that we call auto routers or auto routers that can automate that process. The problem being that those routers, they generally do not integrate the constraints that we need for these traces, right? So trace width is something that auto routers have a problem doing. The problem with the alt and the control PCBs is that they employ that problem. They employ auto routers, but they do it in a very, very unforgiving way, because it happens like this. At the same time that I'm telling you guys all of these technical constraints and all of these technical reasons why I design my PCBs in certain ways, certain traces, they really don't care about that. So the 5-volt trace, it doesn't care how it's routed because it's a very slow signal. It does care about trace thickness because of the current that's going through it, but it doesn't care about geometry at all. The row traces, they really can be traced in almost any way that you want. Thorkin, subscribe. Thank you so much, man. Thornkin, that's an awesome name. So what people generally do is that they take the very delicate traces, like the USB trace, the crystal traces. They route those manually using the constraints that they want. And for all the other traces that don't need all of that care, they use AutoRouter. That's a kind of more educated and efficient way to use AutoRouter, and that's valid. Some people need efficiency, some people need time, and that's fine. The problem with the control and the out is that they do that in a horrible way. So first things first, look at this. By the way, I'm already giving the credits here, right? So this link here, this dude here uploaded apparently. Thank you so much for uploading this, and here is the credits. But take a look at this. Can you guys see these traces? Like, look at this. Senencito, subscribe. Thank you so much, man. Look at this. Can you see these traces? They were done with the... I don't like to curse, but they were done in the shittiest way possible. This is a bad PCB. This is not a good PCB. The silk screen sucks. The cutouts suck. The layout here, this layout here sucks. It's very badly organized. The way that they implemented the whole thing sucks big blue balls. Like, what the heck is this? Is this a fuse? This is a capacitor. Look at the size of this capacitor. The USB here is a mid-mount, okay, but the traces are all effed up. See, look at this. Like, this is a bad PCB. This is a horrible PCB. Look at the vias. Look at the via. Look at this. This looks like my face when I was a teenager, like full of pimples, right? That's what this is. It's a teenager face PCB. This is what that is, right? By the way, this is not a shit on Mastrop. Mastrop is a company that has brought us many awesome things, like MT3, right? I love it. Working from home, subscribe. Thank you so much, man. But this is a PCB that I'm not comfortable. I wouldn't put this up. I would be ashamed as a designer if I put this up, right? Teenager face. Yeah, that's what it is. See, the pimples? This is a teenager face. That's what this is. I'm gonna use that term for now. Yeah, that's what it is. Thanks for the explanation. Thank you for subscribing, my man. By the way, guys, all the subscription money is used for open source projects, for prototyping open source stuff and getting back to the community. So I just don't get the money to eat it fancy. I just open source stuff with this. So all the money that you guys send me is getting back to the community itself. So this is a bad PCB, dude. I'm sorry, but it's a crap PCB. There's nothing that I can do about this, right? And you can see like many. This is what we call red bytes. So in a factory setting, you don't manufacture one PCB at a time. You serialize many PCBs and manufacture 5 or 6 PCBs in a row, and you connect them through what we call red bytes. This is bad panelizing. They do it in panels. That's what you call it. Panels of multiple PCBs. And the way that we snap the PCBs off is through what we call red bytes. And this is bad, man. This is bad usage of red bytes. So I can spend days talking about the problems of these PCBs. Literal days. I exist, therefore I think. Gave me 300 bits. Thank you so much, man. Thank you so much. I don't see a donate link on his site. I don't have a donation link. Should I set that up? What do you guys think? Should I set that up? What is a better way to do mouse bytes? Like this. So in order not to have these lasting marks here, you generally design red bytes a little bit farther away from what they should be. So what you do, a good penalization would be this here. Here, mouse bytes or red bytes, right? So, by the way, these red bytes that I'm showing you guys is standardized. These are not. I can see from here that they just use mouse bytes out of their whatever, wherever they got those. Mouse bytes, they have standards. They are electrical international standards by very well known institutes that about how red bytes and mouse bytes should be done. These here are done through standards from IPC, International. I forget what it stands for, but it's a very well-known institute of engineering that has that kind of standard. See, IPC 37351 is the standard. So, IPC standard 7351. There you go. So what the standard here is, it defines overall guidelines for surface mount design, right? So if you want to design a surface mount board, you should absolutely take a look into this to see how it's done and how it should be done, right? Inside those guidelines and that standard is how you should do mouse bytes. The size of the drill and the spacing of the drills, I3E, that's another one. It also has a standard, right? The way that you should do mouse bytes is what Drop has done is this. They place the mouse bytes right at the middle of the edge here, right? What you should do instead is place it a little bit backwards. If you place it a little bit backwards, some material will be left off, and then the user can shave that off. He can use like a nail file to remove that, right? So you will have a perfect horizontal surface, which looks better, which looks way better, right? It's so simple. You just have to do this. Instead of doing this, you have to do this. By the way, this distance here is also standardized. If I remember correctly, it's 0.5 millimeters or something. Let me get. Yeah, it's 0.5 millimeters or 0.25, something like that. Let me see. Let me get the grid here. Hold on. So it should be something like this, right? So yeah. So yeah, the control and the alt are bad PCBs. They are badly designed. Not much care was taken into designing them, and that's why we don't like them. That's why we rage whenever we see one. Lots of things. I could spend the day here. Just like, I can see 5 or 6 problems. I can see 5 or 6 problems. Like just from the top of my head here. Oh man, auto routing, fuck that shit. Yeah. Did you see the video that someone had a walkie-talkie near the drop and the LHB? Of course they start going crazy because it's badly routed. So it probably, okay, it uses an SSI chip probably? Let's see. Yeah, here it is, see? So this is probably the SSI chip. Where is the filtering? What power filter does this use? What EMI filter does this use? Does this have a shield protection? No, it doesn't. It has a fuse. No ESD apparently. These here might be ESD chips, but anyways, no EMI. So any possible EMI that this takes, it's gonna reflect in the PCB somehow. Choo choo! Thank you guys so much for this. It's a hype train. Thank you. It uses 2 3733s, which is a ridiculous thing to use. Like I can see. Do you see that there are 2 traces too close? Like, hold on. You see here, I can see these two traces here. I don't know if you guys can see, but these two traces here, and this here is the ground pin for this ship. They did it so horribly that they had to put a via for ground. And this pin here is a power ground. You can't do this. This is not a good way to do this. So, yeah, anyways, the thing is, I don't like to talk badly about other people, but about other people's works, but they're designers. It's not in my nature to badmouth people, especially behind their backs. But I think it's absolutely, these caps here are badly done. Anyways, I think that it is, as a designer, it is it is in my power and in my responsibility to tell you guys what a good product looks like. And this, there's USD, but also a USB mux, so you can change USB port as a UFP and with the DFP. That's cool, but you can see that this was done with absolutely no integrity whatsoever. Like, if this had USB mux... Okay, now, you know the problem with what UFP and DFP is now, guys? UFP mean upstream devices, and the other mean, DFP means downstream devices. Or downstream port, right? Down facing or up facing, that kind of thing. By the USB 2.0 standards, and this is not me, you can look at the standard, it's publicly available. Upstream, downstream facing ports or upstream device should integrate voltage polarity protection, ESD protection, fuse protection, over current and over voltage. Fuse is the same thing as over current, but over voltage USB protection. So they should have implemented that on both of the USBs, and they should have placed some termination resistors here, the 22 resistors, to avoid reflection of the signal. Gotta go to sleep, but have a great night. Great night, dude. Thank you so much for being here, Mosaic Dev. So yeah, it's an awesome feature, but it was done in a bad way. I'm sorry. Also, I want to know what these are. What the heck are these? I have no idea. But anyways, if they wanted to do that thing that they want to do, then they should have used a USB hub. As simple as that. I think that might be a multi-diode. Probably it can be a multi-diode, which would be weird because you're using single diodes here, right? And there are also fabrication problems. You can see that this is a poor quality PCB because the cutouts are fucked. Can you see this cutout here? Can you see that the milling here is bad? So this was probably done in a very bad fab. By the way, this has passed QC, so their QC is something to be worried about. Look at this. Like, look at the chipping. Look at the bad machining here. It has a USB 242 hub on it. I see. This here, see, these are fiduciaries. These are fiduciaries to locate a PCB. Most fabs don't need this. Most good fabs don't use this. Don't need this. Okay, so these here, I think, are the MUX, are the multiplexer circuits that these are. See, these are quite near the USB, not as near as I would like, but these are way too far apart. See here? Where are they? Way too far apart. Eventual Entropy subscribed. Thank you so much, dude. Glad to see you again. Glad to see you here. Thank you for the subscription, man. So yeah, lots of problems going around here. Then again, after everything that I've said, after this /rent that I've done, this is not a take on Drop. This is not a take on whoever designed this. This is just I'm just, you know, an affirmation of this could and should be better given the multi-million company that Drop is. I'm gonna go now. I'm gonna catch the VOD later, and don't forget to set up the donation page. What platform should I use? Open Collective. Let's see. Okay. I'll set something up. They mentioned that there is a revised PCB coming for the longest time. Hopefully they fix the issue. Hopefully. We do expect one, because this here is meh. You know something? I think I should do this. This should... Yeah, I think that this is better. Awesome, awesome, awesome. Done. There we go. Let's do that on the 87S2. This is H. Let's do it on H2. Also, to finish the rant, guys, I'm not the be-all, know-all guy. I'm just a guy that has some experience with this. There are other awesome PCB designers, Zark being one of them. Zark knows his stuff. That might correct me or give me, you know, a heads up if I said anything wrong. So if I did, please tell me. You should reuse the reinforced hot swap sockets. Should I? Should I now? Let's do that tomorrow, okay? It's 11 p.m. here, and I want to take a look at the other project. Let's do that tomorrow. Might take a while because you need to redesign some things if you did use the enforced ones. Not so much. Not so much, no. What did you do to the USB port in order to be breakable? Mouse bites as what talk? Yes, I did use mouse bites. Can you see these? So these are the mouse bites. This, and this. There are other vias. Those are meant for the USB traces, but they are also help, right? You can see that I did what I talked about before, where I want the PCB to break in this line, and I've placed them a little bit backwards, right? A little bit upwards, so it leaves you a little bit of material if you want to cut it off or file it off. So that's what I did. This hasn't been prototyped yet, so I don't know how well this breakout is, but it should be workable. Sorry, guys. Can I do this? I think that this is way better. Let me do this. Nice. Besides Sagittarius, are you working on recent PCBs? Quite a few. Quite some, yeah. I wish I had you as a senior. I learned more here than I do at work sometimes. That's how I learned too. Thank you for the compliment, by the way. So this is patch 1.1.1. The KiCad schematic was kept the same, pretty much. So it's still 1.1.0. Need to reroute the gen. Good luck. Just make a left and right. It's that simple, dude. What are you complaining about? Just make a left PCB and a right PCB. Yeah, I'm trying to find any defects with the routing, but I can't see none. So I think it's pretty okay. Check DRC. It was DRC'd before. Let's see for 87S. Let's also do this. This goes here and HS goes here. Let's see. Let's close this. Okay, this is weird. Board setup constraints, copper areas. Oh, hold on. There we go. The minimum through hole, 12. Oh, board setup, allow, okay. Let's check again. There's a lot more DRC checks in KiCad Nightly. Yes, the DRCs here are amazing. I love them. There we go. Yeah, I did these as vias, you see, not as holes per se. So that's why it's, you know, bitching about the annular width. I don't know how you would do differently though. Maybe I should swap nightly. They are hex stable. The latest ones. I really recommend that you do, because there are lots of stuff that you're missing on, man. Really. The only thing that they haven't fixed yet are the routing. The routing is still a bit clunky, but they're on it. You'd have to make them mechanicals, pretty much. Yes, sir. Let me do that. So how much did I do this? 20 mils. Let's change this song, shall we? Do you guys like synthwave? Is there any Monster Cats synthwave stuff? Let's get some nice synths. This song was repetitive. Yeah, it was meh. Okay, so we can fix the violations. Okay, so here we have a very bad one. How the heck didn't I see this before? So done. Okay, so this is done. Oh, okay. Oh, this song is awesome. What the heck? Copper areas intersect. This is weird, okay? Because what I generally do for logos is that I do this no net copper fill here so that it fills the characters. If I delete this, it doesn't fill the characters. And it's weird. It gets weird. So it does copper areas stuff, but it's, see here, it's pretty nah. Yeah, here we do have a problem in that the board edge cuts through the pad. Nothing we can do about this particularly. This here is fine because I designed it this way to build just like a lip for the screw stab. This is fine. Fine. Same thing. Same thing here. The board edge cuts through the pad, but I've made sure that this is not critical, and I'll show you guys later in the renders, but this is fine. I made sure that this is fine. Drill out of range. Oh, this is the thing is, I've used a drill of 0.1 millimeters, if I remember correctly. 0.1. 11.81 mils is what? 0.25. Yeah, 0.25 millimeters, which is perfectly fine, but it's just a little bit lower than 12. Perfectly fine. It's also gonna do malformed outline. Here, this is a problem of the Bezier curves. This is just KiCad being KiCad. But it's fine. It renders fine. It does its job. Unresolved text variable. It's because of the annotations. Like, nah. So yeah, this is perfect fine. Schematic parity. It's accusing problems of the mouse bytes. So meh. This is perfectly fine too. So yeah, DRC is finerino. You guys hearing this song? This is amazing. What the heck? Let me get Spotify back. This song is awesome. Let's hear the album. Damn, this is so nice. This is really neat. Okay, so this is the pad, guys, see? So it cuts through the middle of the pad, but the hot swap socket is just in range. So why not? Here we have a problem with the pad here, see? But also no problems with this one. So yeah. This is for the Space 80. No, this is a universal TKL. It should work with almost any TKL out there. Okay. Let's run DRC for the 87HS. Yeah, same issues here, right? Let's do this, hold on. We also had a problem here, right? Where is it? This guy. Perfect. Damn, this is some neat song. What the heck? This playlist is killer. I have no idea why, but it keeps changing back to the old. Classes. Why does it keep getting back to Oh, awesome. God damn, such awesome music. Swag King. That's an awesome name. Okay, this is a problem. This here, not so much. Why hasn't it copied over the net list? I have zero idea. But this should be 20. Yeah, then we have probably the same issues, right? Yeah, then we go copper intersection areas, drill out of range, outlines, the arcs, new text variable. Yeah, same thing. Man, sleep loud. Thanks for that, please. Keep getting better. You too, man. Hope you have a nice night. Okay, this is a problem. Apparently there's no safe place for this via here. Like so, should be fine. Yep, all solved now. Awesome, yep. It is what it is, dude. There we go. $11.81. How much is this? Control U. Yeah, 0.3 millimeters, right? which probably is the minimum minimum drill. Let's see, PCB. Let's see GLC PCB's capabilities. Okay. The minimum is 0.2. It's perfectly fine. 0.3 is perfectly fine. The minimum clearance is what? .5, like 12 mils or something. 0.254. Come on, what's the how much is this in freedom units? 0.254 is 10, right? 10 mils. PTH to track 0.33, like 15 mils or something. Perfectly fine. So yeah, this is okay. Just so we don't have those problems, let me do this. Should be fine. Damn, so nice, so many nice songs in this playlist. I'm pretty nice. I'm surprised, honestly. Let's see. There we go. No more drill issues. So yeah, just copper area stuff and outlines, which is just KiCad's vectorized engine issues, I guess. Close. Get push and push stacks. There we go. Damn, we didn't have time to take a look at the other project, right? Tomorrow we can do that. Well, this is pretty much we had for today, guys. Do you guys have any more questions? Do you guys have any more suggestions? This is the time. Thank you guys for everyone that subscribed. So mod actions, how do I see the events? PVD feed. Eventual entropy subscribed. I exist therefore think cheered. Working from home subscribed. Senencito subscribed. Thornkin subscribed. Doge OC followed. Kruger Live followed. Live. Zekin Zach rated and followed. Thank you so much, man. Crowbit, the man, the myth, the legend followed. Thank you so much. Zekin rated. Damn, so nice. Karma subscribed. Thank you so much, guys. This is pretty much it. If you guys want to check out the project, here it is. It's in my, I should change this to the Akron project ownership, but here it is if you guys want to check this out. No questions? No more questions, I guess. No more questions, I guess. Well, okay, it is what it is. Let's raid someone. So we have Merlin. Apparently Gateron makes hot swap sockets now too. Yeah, pretty much. Tomorrow we are going to add the stress reliefs for the hot swap sockets. Just pick some up from off KBD. Tell me how they went. Tell me how those went. I'm curious to know. So guys, should we raid? So we have Stray Chroma, awesome. I love her streams. Mac Marling, Max on deck, Yamaru, and Chubbies. Let's see what these people are doing. So Yamaru is doing Rama M65B build stream. Max on deck is doing a Mac Madness stream, awesome. Merling is doing a port, no, the KBD67 unboxing, and Chroma is doing keyboards, looks like a 75%. Who should we raid? Gateron, not Kale. Yep, I'm aware. Tell me how they are. We could use those later too. No suggestions to who we should raid, guys? I guess not. Okay, let's raid Merlin, because Merlin's amazing. I love him. Shameless QMK plug. Yeah, no QMK shameless plug, because Merlin is awesome. I may or may not have bought 20k directly from Gateron. May or may not have bought 20,000 units of something. Is not a good phrase, dude. Anyways, let's raid Merlin. You guys have an awesome night. Thank you guys so much for being here. And tomorrow we'll be here, not at the same time, probably at the same time, doing other projects. So I hope to see you guys there. I love you guys. Thank you for being here. Stay awesome. Thank you guys so much. Godspeed. By the way, raid message is I came from Brazil. Raid message. Thank you guys so much. Bye bye.
KB67 Light R1. This is the same